I'll pull it up. And this README here has all the information about it. What we're going to do is we're going to structure it by days. So this right now is essentially day 0, but then tomorrow or later on, if you want to go back in time, you could check out day 1, which will be where we were at the end of this day. You can check out day 2 and so on and so forth. This will also help anybody who can't make it today. They can jump and be exactly where we are if you want to follow along.
Real quick, can everybody hear okay?
The big tools we're going to be needing are Git, and there's some links there for Windows and for Mac. I've already got it installed. And then Node and NPM. So if you just go to this Node download, there's an installer for Windows, Mac, and everything else. That also installs NPM as part of that. You can check if you have it installed already by just doing node-v or npm-v or git-version. We also need Java installed. It's somewhat likely you probably already have this. And this is, we are coding in Node for WebDriver.io, but the Selenium server runs in Java, so we just need to make sure that that's set up on your machine. And that's Java version. Make sure that you're getting some output of that. And then once you've got Node and NPM installed, you want to go npm install -g. G stands for global, Mocha. And Mocha is the test runner where we're wrapping around our stuff. If this gives you some danger, or gives you some warning, you might, and you're on a Mac or Linux, you might have to do sudo npm install -g Mocha. It all depends on how you got set up and what kind of rights you have on your machine. And then it's probably also worth, especially if you're on a Mac, just doing that for Chrome driver as well. So npm install -g Chrome driver. For Windows, we have to do a little separately. But you can also do this on a Windows machine. It just won't be what we're actually using. So this is going to set up Chrome driver, which is going to allow us to work with both Firefox and Chrome. And if it works, you should be able to say Chrome driver -v and get that same information. And then finally, I would say you want to pick an IDE. There are 3 I've listed here, but really anyone that works for you. You could use Notepad++ if you really want to. Node is a just-in-time compiled language, so you're not going to get a lot of the features that you might get from Eclipse or Visual Studio. But some of these newer ones are actually pretty sharp. So IntelliJ actually kind of does some behind-the-scenes just-in-time compiling to try and help determine where stuff is coming from. And that's probably your best bet if you have a license. If you don't have a license, there's a 30-day free trial you can get pulled down and see. Otherwise, Visual Studio Code's very popular. It also, I think, has a decent feature set that's built up right away. And I'll be working in Atom, but that's just because what I'm most familiar with. If you choose Atom, there's a number of packages you need to install, especially for JavaScript and the JavaScript hints. So, or just Google, Node IDE or JavaScript IDE, and I'm sure you'll find tons of options. So pick whichever one you feel works best for you. All right. So then the next thing is we're going to go, I usually go to my home directory, but you can go anywhere you want to. I'm going to make a directory. I would say call it Git. This is nice just because it's easy to remember. So once you're in there, so MK, if you're on a Mac, mkdir, Git, and on Windows, I think it's MD, creating a directory. MKDR for Windows.
Or DIR,
yeah.
Sorry.
Oh, all right, so it's the same. So once you're in Git, we're going to want to clone down. And if you haven't worked with Git before, it's pretty straightforward. So on this GitHub thing, there's this drop down that says clone or download. So it's got a link there. So you just want to copy that to your clipboard. And then you just type git clone and paste that link in. And it's going to take a little bit because we have the Selenium server packaged in there. We have some other stuff packaged in there. But you might not necessarily do that with your own framework. But this is going to create a directory in there called West Denver Meetup Framework, all one word. And as soon as it's done cloning, we'll go in there and we will install. What's it? Just scroll up to the top. There's a little green drop down or something. I apologize. Apparently, you probably need to sign up for GitHub in order to clone, but it's free. Yeah. Okay. Once it's in, we can then cd into that directory, so West Denver Meetup Framework. Okay. Okay. And so here you can see we've pulled down everything. And we wanted to structure this event, so we're building as much of the framework as we can. But we did do a little bit of work up front just to make it easier for everyone to get started. I'll talk about what that is right now. First of all, we have this pre-built one that's just a very simple kind of version of a framework we're going to be building today. But that's just there for reference. And we also created this batch script for Windows drivers. So part of this is for the API testing portion, we have a test server. And we want to make sure that works. So the first thing we have to do is install. So we're in the West Denver one, so you can type npm install once you've changed into that directory. And this is going to pull everything in. This is one of the reasons we chose Node for this, is because the setup cost is very straightforward. If we were working with Eclipse or Maven, we would probably have to have a whole day session just for that. And even then, it would be unlikely that everybody would be working. So it's convenient that you can do this. It's going to pull everything in right away, just like that, usually without any problems. And then once you're installed, the first thing we want to do is check out that our test server is up and running. So you can type in node test server server.js, and this is in the README. So what this does, and we're not going to be using it today, but we have this here. Hello and welcome to the test server. We're going to be using this to test our own API. So when we get to the API testing portion, probably next session, we have our own setup, so that way we can all test the same APIs back and forth. But an interesting thing about this is we could set up our own UI if we wanted to. So if you wanted to have tests for your own framework, you can build your own simple website and go around and interact with it. But as far as the setup goes, you just want to make sure that when you go to localhost 3000, that you see this. And once that is working, you'll notice that you can't run any commands anymore. You have to hit Control-C to get out of the server. So that's the first step to make sure you're set up. The next step is we want to make sure that we can run the Selenium server. And here's where it actually is going to differ between Mac and Windows. So Windows, we have a special batch script. So you can do start server win. .bat. I can't run it because I'm not on Windows. But that should kick off the Selenium server. And if you see it's running and it does kind of like this, basically you should see output like this. And it should end with Selenium servers up and running. And just like our test server, it's taken away our cursor. But in this case, we want to leave this running. This is what's going to make your browser actually work when we start getting into the UI framework. So, and then the final thing is we want to run a quick test just to make sure that it works. So we're in the main West Denver room again. We've got the Selenium server up and running. So we're just going to call Mocha this UI test pre-built, and we have this basic test. And this is just going to run something where we open up a browser and open up Google, and then we open up eBay, and it searches for a new camera. So now we know everything's wired up, and that's just important for that. I would say if you get stuck or you get stuck on the setup, we'll definitely help you, and we'll have, this is recorded, but we're going to try and keep moving forward so we get to the actual framework building. There's a troubleshooting section on the setup that goes into detail for issues like the browser opens but it doesn't load, the browser doesn't open, other things like that, and we'll keep this updated with other information. So now we're going to actually talk about building a framework. And I have some slides. I'll put them out there. We're not going to go through them so much for this session, but just know that we have slides kind of talking about what the thing is. But basically, our goal is to create a framework that's usable, and that anybody can pick it up and work with it without a lot of training. We want it that's consistent, so your tests pass consistently. One of the big problems with UI automation in general is it's very hard to stay consistent. There's a lot of false negatives, a lot of things that fail and pass and fail and pass. Another thing is we want really readable test results. A framework lives or dies by the test results, right? If you just send a stack trace of gibberish, no one's going to fix it. No one's going to care what it is. So this is actually, usually this is what's deprioritized, and I think is one of the big mistakes people do when they build frameworks, is you should always be focusing on what's it outputting. What does it look like when a test fails? So I think people they see tests passing, they pat themselves on the back, and then the tests start failing and they realize they left out an important part. And we want it to be quick to create new tests. What we're not prioritizing is we're not trying to make it as efficient as possible through computer science, and we're not trying to make it fast. We do take this into consideration, but these are not our priority. One of the things we're going to talk about is it's not going to be the best framework in the world. The idea behind it is this is something you could spin up in a half a day at any place you have to, and it can work, and it can stay consistent for a while. And then you can work on building a more fancy or in-depth framework, but this will work for most companies' needs. Tech stack is Node, WebDriver for tests, and some other things. We'll talk about why Node throughout part of it. The barest bones of a framework, especially for a UI framework, is two things. You are finding something, and you are interacting with it, right? That's all a UI framework boils down to. You're finding a button, you're clicking the button. You're finding some text, you're reading that text. So that's all we want to keep in mind as we keep writing these tests. So I have a little diagram here. Here's the general idea of the framework we're going to build. Here we have our web page, our actual application we're testing. Just like we talked about, there's finding and there's interacting with. So there's elements, and that is things on the page, and there's actions, and those are things you can do to the page. And for this case, we're going to count reading as an action, right? You can retrieve information, you can count, you can see if something's displayed or not. The big part of our framework is we're going to store all our element information in a separate file. And we'll talk about why we're doing this for sure. And then we're going to put all our actions in a page object. So that page object only contains the actions, all the elements that it interacts with are in its own separate file. We're going to have a separate custom commands object that kind of wraps the existing WebDriver and Selenium ones with our own. The reason for that is our locators are going to have to be special. They're going to have to be their own thing. So when we say click, we've got to be able to click something that's in our format. So we're redefining elements to be in our format. And that's not just because we're egotistical. There's a reason for that, and you'll see that. And then the page object can then interact with those. And we're going to have a very simple concept of a page collection, and that's going to hold all our pages together. And this is solely for readability and some refactoring purposes. As we build this framework, I'm going to leave some parts out, and then we will add them back in later on to show you the idea of because we designed it this way, it's easier to expand. It's easier to add on top of. And then finally, we have the test. And I have this extra line for custom commands because in theory, the test should only be talking to the page collection. But in reality, there's going to be times where you just need to do a quick command. You don't want to go and add another function to a page for just a one-off. So we are going to support that. And finally, we have this concept of test data and API helpers. We'll be talking about this on later days. But this is going to be to, once you've got the bones of the framework in place, to really kick it up so you can start doing things like dynamically setting up and tearing down data and other things like that. And this test data is going to be used for data driving. So today, we're just going to be focusing on this: the locator, the custom commands, the page object, the page collection, and the tests themselves. So we can finally get started. All right. So here I'm going to open my clone framework, which is under Denver Meetup. Yeah. And I'm going to create a new folder. I'm going to call it my new framework. You call it whatever you want. Right. This is, I think, anyone who decides they want to build a framework, they get to this point, and it's kind of scary. You've got a folder, and you don't know what you want to do from that point on. So at least we have a diagram at a time, so we can start breaking it up a little bit. So I say, well, I know I want files to contain element information, so I'm going to have locators, and then I know I want pages, right? I want page objects, so I'm going to have a folder to keep hold of those page objects. And I'm probably going to want a folder for tests. Oops, that's a file. So we have locators, pages, and tests. And this is probably going to be enough, but we also had that custom command. So we're probably going to have some ambiguous concept of helpers. So we can call it helpers or we can call it lib. I like to call it lib just to kind of indicate that this is support. This is things to support the framework. So I did it again, sorry. So we have our lib folder. Okay, so we got some time, so we'll kind of go at it as how you might normally go at it. We're going to start with basic scripting, right? We're going to start with a basic scripting test that doesn't use any framework whatsoever, and we'll kind of revisit it just so we can get familiar with WebDriver itself. So we mentioned in the setup, but the test runner we're using is called Mocha, and we're going to kind of see a lot of JavaScript concepts here. And if it doesn't make sense, I would say just don't worry. We'll keep revisiting and we'll keep talking about that. But Mocha is a behavioral-driven test runner, so it follows a kind of system of describe. So describe you can think of as the top level. So I'm going to say basic tests without a framework. And here's where it gets JavaScript-y. The second argument to describe is a function. Right, and everything inside of here is going to be that. And we will talk about what this means maybe at a later date. But for now, just kind of take it as, okay, this is how you set it up. Like when you first started with Java and someone told you to do static void main, you just have to take it as a reason for now. And hopefully, as you get more comfortable, you'll start to figure out what it means. So then under describe, we're going to have it. So here, it is actually the concept of a test. And it might not make sense initially, but it's kind of like, if you think about it in English. So it statements are usually like, should open Google, right? So that's what the it stands for, because it should read as, I'm describing this group of tests, and I'm saying this specific test, it should do this. And again, the exact same thing happens here. We add a function. And here's where we would want to write a test. We're going to say, I want to open a browser I want to load Google. So the way WebDriver IO works is you can just require it. So in JavaScript, you can pull a library in by just saying require, and you just put it in quotes. So I'm saying WebDriver IO. And if you're wondering where that's coming from, there's this package.json, and it has all these dependencies. So you can see we have WebDriver IO here. So here's where we could change the version or whatnot. If you find a library you like, you can add it here. And whenever you do that npm install, it finds all of these dependencies and loads them. So as long as you have that in your package, you can say require and just put it in quotes. We also are going to use require statements to pull in our own libraries, but we'll get to that when we do. So I'm going to reference the pre-built test really quick because I need this information. All right. Options. All right. Yeah. We're going to put this all in one test here. We'll talk about breaking it out in a bit. So options are, this is kind of the basic every WebDriver thing, how you start something. So we're saying when I run WebDriver, I want a browser name, and I'm going to call it Firefox, right? And then and so this is saying, talk to the Selenium server, pass it this information. The Selenium server has the same port, so that's why it basically does that. So here's where we're saying, I want to start a Firefox browser, and it's going to run out and start that browser for us. And so that's going to start a browser for us. And at this point, we can check. We can see if we're on track. So can I call it? All right, so to run a test, you just type Mocha. I call it my new framework. Tests, basic scripting. So you just pass Mocha and then the directory path to your test. If you leave it off, it's going to run everything in that directory. All right. So you may have noticed that the test finished and then it opened a browser. So clearly something is wrong. This is a good point to talk about callbacks. So basically the way Node works, and the thing that drives most people crazy about it, is any kind of input-output, it immediately throws it on a stack and continues on. So starting a browser definitely counts as input-output. So it gets here, and it says he wants to start a browser, so he throws it on a stack, and then it continues on. So this is how it gets to be so fast. As a result, it can be kind of strange. But anyways, how we handle that is we tell this script that we're taking a callback in. We're saying, we're not done until you call this method called done. And so I can say done when we reach the end. And another way to do it is we can just say return. So this means it's not done until you've reached the end of this return. So we can try both ways. Yeah, so now we launched a browser. Now we have the other problem. It didn't end. That's because we added this done in. So when you add done, it won't finish until you actually call done. But the issue is we put a return here. So it's saying, I'm done. When it returns here, it says, as soon as this series of commands ends, I'm done. So it never gets to this line. This is an example also because it's not a compiled language per se like Node or C#, they wouldn't let you get there. You couldn't get past this in Eclipse or anything like that because it would say, this is unexecutable code. You have something after the return statement. This is never going to happen. So some of the trade-offs we get for the flexibility is that you get a lot more runtime kind of crazy errors. There we go. So it passed. So we started a browser. We didn't kill the browser. The next step would be end, and that will kill it. And then a basic script would be we want to load Google, right? So, and all of this you can find if you Google WebDriver IO API. You can find out the name of all these methods. This is just a basic example. So the first thing we want to do is we probably want to split out, we'll call it better scripting. Actually, we'll just copy this. And this we're going to be a little bit smart. We're going to use it before and after. Better scripting. Because we know when you're running a test, you're always going to start the browser, and you're always going to want to shut it down when you're done. So Mocha allows that. You have the same concept of before, and it takes a function, or before each. So before will be just once. So we have this, what they call a describe block. If we had multiple of these it tests in here, it would run once for all of those tests. Before each will run before every single test. So we're going to do before each because we want it to start the browser for each test. So we're going to say for each function. And we're just going to take this code and throw it in here. And the thing we want is once we start the browser, we need to know where it is. We need to pass it between ourselves and handle it. So we're going to want to assign it. And the nice thing about Node is it's not typed, right? So I can just say, I'm going to have something called a driver. It could be a string. It could be an integer. It could be anything. And we're going to say driver equals this, right? So now anything on this page can access this driver, which is good because that's what our tests are going to want to do. And our framework at some point is going to make a big use of this before each statement. So, and then we're going to want the same thing just like before. We're going to want to do an after each. So we've started the browser, and now we're going to end it. Same idea. Just like before we added this .end, we've just assigned driver to this state. So driver is at the same state as it was when we had before we added .end. So we can just say after each, shut it down. And now our test doesn't do anything, but because it exists, it's going to start a browser and it's going to end it. And we're going to try that out real quick. So it starts a browser, and then we ran out of time. If you want to set timeout on Mocha, it defaults to 2 seconds. That's never enough for a UI test, so you just type this .timeout. Nope, this timeout, and we'll set it to 30 seconds. And we're going to put this done in here like we talked about. And we're saying don't end the script until we've reached this point. So now we're going to run it. Let's see if it closes our browser when it's done, which it does not look like it did. Oh, because I'm running the wrong test. I'm sorry. We're running better scripting. Okay. All right. So this is the example of now you're moving down the path of starting a framework. You've realized that you're going to be doing stuff again and again, so we have a before and an after. The next kind of iteration of a framework, which we're going to skip over, would be, say you have a lot of tests. Let's see if I have a PowerPoint for this. So here's your basic framework. And then you have then you start adding libraries. You're like, you know what, I'm logging in a lot. I don't need to copy and paste that code, so I have this helper method, and I can call login. And I can call go to change password, and I can call this. And what eventually happens then is your helper library becomes too big and too unmanageable. So you get to a more abstract state, and that's where we are, where we want to kind of conceptually treat every web page as its own separate object. So if we go to eBay, we can call it eBay Home. And even more so, we can break this up. You can say eBay search bar, eBay top menu, right? eBay footer. We can break this page up into objects, and we can break each individual page up into objects. And that's basic idea behind the page object framework is by doing that, it's going to help limit your tests, and it's going to make them a lot easier to manage. So the first thing we want to do for eBay is we want to have locators. And we don't have time to go into specific about how you find locators. So you just have to trust me on this, but you can always read about CSS or XPath. But basically there's a way that you can look at the HTML and you can decide on a locator. So here's the search bar I'm looking at, and it has an ID of GH-AC. And we're probably going to want this search button. And this has an ID of GH-BTN. So getting into the actual framework building now, we're going to create a locator file called eBay. We'll make it out here, eBay home.json. Right, so if you're familiar with JSON, it's pretty straightforward. We're going to create, each property is going to be the name of the element, so we're going to call it top search bar. That's going to be an object, and we're going to call the other one top search button. And obviously, you can imagine adding multiple elements in here for every page, every breakdown of every page you want. So, and we know we're going to want a page object with the same name. We're going to have eBay home. So there's going to be a one-to-one relationship. Each page has a locator file and vice versa. So we know we want these two buttons. We want to put some information for them to have. So we're going to want a description. And this is one of the key points of the framework is it's going to allow us to have readable output. So instead of just seeing that, if you saw the GH-AC, that's very hard for anyone to know what it means. So in this case, I can say search bar at top of the page. And we're going to have a locator. This is the simplest as we can get right now. Where's eBay? What was it? GH-AC. So in CSS, an ID is just a pound sign, GH-AC. You'll just have to trust me on it, but that's enough to tell the browser how to find it. And you can check this out by just copying this. And you can always search for it in Chrome. You can see I put pound GH-AC and it knew what I meant. It says, oh, here's that element you're looking for. And then doing the same with our search button. GH-BTN. So again, we're just going to add a description. Search button at top of page and a locator. GH-BTN. So we have this information about our elements. The next thing we know is we want our page to be able to load this information in, right? We know the name of the page we want it to pull in. But we don't even we have a blank file here for a page. So if we want the idea of a page. So when classes in JavaScript are kind of strange, they start with just function by itself. This is essentially the constructor. And then you say module.exports equals eBay home. And again, we can do a lot of reading on that, but in the interest of time, it's going to be, this is how you create a class in JavaScript. If you want to add a method, you say eBay home.prototype. And we're going to say we want a method called open. And that's going to be a function. And we're going to, open the eBay home page. All right, and now you can imagine we'll have other stuff, like we'll have something that says search for eBay home.prototype.search for. We're going to say text to search for. And this is a perfectly valid strategy when designing a framework. You can stub everything out, and it's going to help you. It's going to help you keep track of what you want to do and what to come back to. So we're going to say type something and search for it. The next thing that's important is we know that we have that driver that we're starting in our test, right? The actual browser. So conceptually, we know a page has to know about the driver. If we're going to search for something, we have to say search for it where? On the browser. So you have two options. One is you can pass it in for every function. We call it the driver. You can say it here, right? And then we can say, all right, they passed in the driver. I can say driver.url. Yeah. But this is going to get really cumbersome, right? Every time we add a function, we have to take the driver. Every time someone calls a function, they got to take the driver. So rather than do that, we'll say when they first create this class, we'll have them pass the driver in there. And then we'll just keep track of it. So what we have here is we're saying this driver is going to be internal. So it's kind of internal to the class. So these functions can interact with it, but not necessarily other things. So we're going to say this driver equals driver. And then this is saying this object right here. So it's saying this right here has something called a driver, and I've got this other driver here. If it's too annoying, you can always change this to say passed in driver. Sometimes, especially when you're just getting started out, it's more conceptually easier to name stuff differently. Otherwise, the this driver equals driver can be a little strange. So what we've said here is we've got this concept of an eBay homepage. And when I create one, I have to give it a driver, and it's storing the driver. And it has a method called open that says, if you call open, I'm going to go to the eBay home. So far, so good. So how would this look in a test? With just this very basics right here. If we go to better scripting, we have our driver. Here's where we can actually start pulling in our own libraries. So I know I want eBay home. So I'm going to say, you give it all caps, or you use capital letters when you're doing classes versus libraries. We haven't seen a library yet, but we'll talk about what that means. And you say require. And unlike WebDriver IO, which is kind of a third party, you have to give it a direct path. So we say from where this file is. So this file is in tests, and we want to get to pages. So I say you got to go up a directory, you got to go to pages, and then you got to go to eBay home. So what happens when node runs? It immediately runs out and pulls all of that in and stores it in this variable. And that allows us to say var eBay home equals new eBay home. And like we said before, it's got to take the driver. So we pass it in the driver. And now we could say eBay home dot open. And that should then open. We'll give it a try. Oh. So no, errors with Mocha can be a little difficult, but it'll always give you a stack trace. And you can always, sometimes it's easy, but you look for files that you know that you touched. So here we say eBay home line 10, and then better scripting line 31, and then the same on 19. So let's go to line 10. Oh. So when I was giving an example of saying passing the driver in, I left that in there. What we really want is to say this dot driver. And actually there's a concept that I can't really explain, but a lot of times you want to do this. Var self equals this. And this is because scoping is very strange in JavaScript, and you can pass stuff around so the scope will change. So this is just a good pattern to get into. So we're just saying var self equals this, and then self.driver. So self is the same as this is me. So I've got something called a driver. All right, looks good so far. I'm going to close some of these Firefox browsers. So now we have the concept of a page. It's at this point that you have an abstract framework, and you can cruise on from here, right? You can easily start saying, once you learn how to make locators, you can create tons of pages for everything in your application and fill out these locator files. Well, you're close. We haven't got to the point where you can actually interact, so let's do that really quick. We know that we want this page to have access to those locators. So we're going to call it locators. And we want to say this locators equals, and we can say require, and again, you can require JSON files the same as you did with JavaScript. So require, and we pass in the path we want to get to. So we want to go up a directory to locators to eBay home.json. You can leave the .json off, but we'll make it here because it's a little easier to figure out. So now you have access to both of these. So your page object has access to the elements. So let's do a very basic typing command. So we're going to say self.driver, and this is the WebDriver IO. So we're still using its basic commands. Set value is how you're going to type something. And the first argument it takes is a locator string. So we know our locator string is under each object, and it's called locator. So that's the name of the field. So I can say set value. So I want to grab my locator. We'll do it this way. So my locator is going to be locators. That's all the elements. And then I want the top search bar, right? So I don't want to hit the button. I want the search bar. So top search bar. And then I want the locator field. So traversing JSON and Node is very straightforward. It's just follow it down and just put dots. So top search bar dot locator. If I wanted a description, I can say dot description. And in fact, we probably do want the description. Right. So now this has that locator, and I can say set value locator, and I can say what I want it to search for, which is going to be, in this case, text to search for. Right? And then I'm going to want to say self driver.click. We want to click the button, so we're probably going to want a second locator, button locator, self.locators, top search, button, top locator. And unlike set value, button doesn't need any extra information. It just needs to know what to click. All right, so now we have the concept of interacting. It may seem a little ridiculous in a round trip to put this information in a file that we load and then pass it back in, but it's going to make more sense as we continue to build it out. Oh, we aren't calling anything. So we go back to our test. We say eBay home.open. Now we can say eBay home.search for orphans. No, not returning them. I'm doing that because we haven't got to the point to talk about asynchronous, but if I return done, it's actually going to end the test before it starts. So I'm letting the test time out. We'll talk about why that's happening in a bit. Nope, it didn't like self on eBay home line 18. Ah, because I never defined it. Equals this. And this is why it's important to try and get things to a testable state. We could have started and tried to build the whole framework from scratch, but this way we got to build it individually and make sure. So as we search for antiques. Let me check really quick. What are my locators? That's their button. That's their search bar. We're calling set value. We're searching for it. We're clicking. So maybe it was just really fast. All right. So at this point, you can go nuts, right? You can do this, and you can start automating right away, and you would do okay. You can have pages, you can have actions for those pages, you can use the built-in WebDriver stuff, and it would be somewhat all right. The nice thing is all your tests that call search for, you just have to update it here, right? So if search for changes, you only have this one spot to update, and all your tests get to change. This is the benefit of kind of abstracting stuff out. But we're going to go a step further. So what I want is we have this description. I really want, when I run a command, to print out this, right? I want the output of my test to say I'm typing orphans in the search bar at the top of the page. I'm clicking the search button at the top of the page. Right? I think that's going to make for really readable output. And I don't want to have a bunch of console statements that I have to write every time I write a test to do that. So here's where we're going to have a concept of custom commands. We're just going to call it commands for brevity. Right. And this is going to be a library. And the difference between an object and a class and a library is, if you remember the class, we created all of that stuff, and then we said module.exports equals the class. Here we're just saying module.exports equals this, and this is just a collection of methods. Right? So I know I'm going to want to click. I know I'm going to want set value. So we just want the exact same methods that WebDriver has, but they're going to be ours. And why are they going to be ours? Because our methods, unlike WebDrivers, take in a special locator object. Right? And I know I want the driver, right? In order to, because we're just wrapping it. So I want, when I call click, I want to take my locator object, print out something, and then pass it on to the regular WebDriver one. So I still need the driver somehow. So I'm going to put that in there. And we're going to call something called set driver, right? So at the start of our test, we can say, I've started the driver. I'm going to give you the driver. So we change this to test. And this, I'm telling you now, is not ideal. We're going to get to a point where we refactor this. We're going to talk about good things to refactor and painful things to refactor and why you want to think ahead about it. But for right now, we're doing it this way to server purpose. So conceptually, someone is going to get this library. They're going to call set driver. They're going to say, here's the driver for all your commands, use that. And then I can then say, I want to click, here's the locator object, and it's going to say, first I want it to print out. I want to say console.log. I am clicking, and I can say locator object dot description, right? So now we're taking advantage of that extra information we provided. Now we're getting nice output. If someone reads your test output, it will look like a regular test. It'll say a lot of I am, but a human being could read it. You can email it to a developer. And then the next thing we want to do is we want to actually click. So we want to say driver.click, locator object, locator. Right? Just that easy. Now, we added a little bit of extra stuff, and we get some nice debug output, and we get everything else we want. It is here you can start to do stuff like, if click fails, try again. Right? One thing at Home Advisor we have is a lot of pop-ups that show up for users, like you want to take this survey. We have stuff built into our framework that say, if the click fails, check if one of those pop-ups is in the way, because it's completely random. If it is, close that and then move on. So now our tests don't have to check for them themselves. It's kind of built into the framework. And we'll talk about a lot of stuff you can do here, but at least initially we're getting this nice debugging. So same with console. It's going to take a locator object. And just like set value for WebDriver, it's going to take something to type, text to type. So the same thing, we're going to say console.log. I am typing, we're going to say text to type into locator object description. If you remember what the description is, this would end up printing out, I am typing something into the search bar at the top of the page. And then all we're doing is just wrapping it, so we just say driver.setValue, the exact same thing that it did, and we pass it our locator. We're only going to do these two commands, so you can imagine that you add more commands here. And we'll get to this in other days too, but we only scratched the surface of this, right? If you've worked with Selenium a lot and your website has frames, you know it's a pain in the ass to change between frames. Now I can say what frame it's in, right? And now in my clicks method, I could say, hey, does it have a frame? If it does, change to that frame first. So now the framework is taking care of that. If it's in a special window, you can do that. If you have to deal with internationalization and you have to support French, you can have separate locators, and you can put that in the click. Hey, do I have are we in French? Are you in French, and does it have a French locator? Then I'm using that special too. Right. And you can go even further. We'll actually do this, but we can say, we can group things together. Right. What this means is this always on the page? And then we can say, yes, this element is, this one isn't, this element is, this one isn't. Then you can have a method to say, find everything that's on this page always, and check that it's there. And so you can do wait for page to load, and it's built in to here. All of this business logic is inside this JSON file. So if you get sick of Node, you've got it. You can rewrite this in Java. All of this information is the same. You want to switch to Python, everything can parse JSON. It's language agnostic. So this is the main value, is the more stuff you add here, all you have to do is write something that knows how to read that. So you can transport your framework everywhere, and you've got this handled. Similarly, you could store this in a database or wherever you want. I personally like JSON. I think it's easier to read and jump back for. We're going to take those out for now, and we're going to wire it up. So we have our commands. Now we want our page to call our commands. So just like with eBay Home, we have to pull this command library in. So our commands equals require, and we want to go up a directory to lib and pull in commands. there's a concept here that we'll talk about where it might be very strange. So here's where we're calling set value now, and all we're going to do is say commands set value because we have that method. But the nice thing about this is I can just pass in the whole object. Right? I don't have to split out the locator. And then we want to say text to search for. And I want to do it again. Commands.click. So locators, top search button. Right. So it looks almost the same. It's a little cleaner because we don't need to do this parsing of the locator. We just say it's got a locator, use that. That has all the information you could possibly need. One thing you can do here is you can say, you can really go crazy. Anything you want, you can say stubborn element. And that says wait longer for it. Right? You can add custom things like this one doesn't work, this one does work. Use jQuery for this only. The sky's the limit. When you run into a problem, you can always say maybe I can just add a field. So this looks like it should work. The problem is we never called that set driver. So you may think, oh, well, here's the driver here, so I can say commands set driver. And that would work. This would work. What we're going to do instead, though, is we're going to set the driver at the test. And we're just going to explain a very interesting thing about JavaScript and Node. So we're going to pull in the commands here. And now we're at the test, so still up one directory to live two commands. And we're going to do it in our before. Command set driver. So if you're familiar with Java or virtually any language, you may be saying, well, that's stupid. You set it here, but when you go over here in your page, you pull a new one. So you're going to have to reset it. And that is not the case. The interesting thing about JavaScript is when you load a library, it loads it just once. Anytime after that, you're getting the same library. So when I set driver here, and then I pull it in anywhere else, it's getting that same driver. Handy for stuff like this, but also incredibly dangerous because you can make some really bad assumptions about what's happening. But we're going to take advantage of that. For now, like we said, we'll probably go back through and refactor when we start talking about how to make it good. But just to be aware that if you set driver here, any place else that calls commands or pulls it in has your driver in it. So it's a de facto singleton. It's not really a singleton, but it kind of behaves like that. All right, so we set the driver. Our page now is calling a custom command, so we can give it a try and see if we get our nice output. You'll notice that output came out really fast. There's a reason for that. I'm typing orphans into the search bar at the top of the page. I'm clicking the search button at the top of the page. Pretty nice. Not bad. So why did this print out before the web page even loaded? That is because we talked about a little bit at the beginning is that Node is throwing every input-output onto a stack. So it ran through before you can even comprehend. And it said, eBay home, new driver, that's fine, I can do that. Open, that's calling a URL, that's input-output, I'll throw that on a stack. Let me know when you're done. Search for, I'm going to say type this in here and click this button, I'm throwing that on a stack, let me know when you're done. As it drove down to the page, it did the same thing. And when it gets to the commands, it says, oh, I can print this out, that takes no time at all. And then here, click, that's input-output, let me know when you're done. So this is a big problem with working in a UI framework in a language like Node because it's infuriating, right? You don't want to put a console output and have it display before it did the thing it's talking about. So here's where we're going to have to take some concepts of blocking and asynchronous to try and force it into a sequential behavior. And like I said, we're doing this in Node, but you can rebuild this in Python or Ruby just as easily, and you don't have to worry about this part. But the same exact concept, I'm fairly sure you can build in any language you want just by reference, right? We didn't do anything groundbreaking here. So we're going to refer to the pre-built. And it's using this concept called promises. And promises are saying, let's look at the commands. Promises are saying, I promise that I will give you a value eventually. So I can return that to somebody, and it will say, here's a value, here's the promise of the value, but don't go any further until you get it. And so you can chain those together, and you get kind of an interesting sequential aspect to it. All right. So let's do that. Here is our search for, so we can say return new promise. So reject. And this is a little weird, but this is kind of the flow of promises. And this says it's the return. We kind of talked about this a little bit. It's the return here that stops the execution. It won't go any further because it's saying this is the end of this function. So then it goes inside here, and it's going to run these. And when we're done with that, we can say return resolve. And here you would return a value if you wanted to. If I wanted to, I could pass the page or the driver along or not. And so if there was an error, I could say, if something went wrong, I can return reject. And what that looks like at a test level is instead of like this, which is sort of good, instead every method from our page we're going to make return a promise. And the way that looks is it gives you the ability to call then. And then always looks like this, return value. So this return value is what that previous promise gave you. So here's how we're going to make our test sequential. If I wanted to call something else, I can say this, and then. And the result of this is you can avoid callbacks, which is the other way to do sequential operations in JavaScript. I won't get into callbacks because it's somewhat complicated, but it stacks further and further and further and further away. And so this is what our goal is. I have not set it up correctly right now, but this is what our goal for the framework is, to get around Node's kind of wackiness, is we want all our tests to look like this. And so if you're familiar with Nightwatch, this is one of the downsides of WebDriver.io is you get a little more of this code noise. Nightwatch has some built-in stuff to make it seem sequential when it's not. So you can actually stack all your commands like that and it looks good. But WebDriver.io doesn't have that. But as a result, it has some stuff that you can do more conditional logic. So there's the benefits to both. So if you're trying to consider one to play with, I would say you can set up the same framework in Nightwatch or WebDriver.io, but just be aware that you'll probably have to use promises or callbacks for this. So we know that this is what our tests are going to look like. eBay, home, do something else. And the key with promises is you're always returning. So the way it works is it's running through your test. It says, oh, return. So I'm done. At this point in its mind, it's done with the test. It says, this is the last command, and we get to enter. So when it does that, it goes to search for. All right, I'm searching for orphans. That returns a promise. And it gets a promise. It's like, all right, again, because you're inside a function, oh, I'm going to call this do something else, and that's the return, so I'm done. So the return keyword is very important. That's how it acts. So if you were playing with promises and you leave a return out, that's the number one issue. And because of that, If it doesn't see a return, it's like, oh, that's input output, I'm going to throw it on the stack. Oh, I'm done. It's going to get to the end. So you'll get something like, if I left return off here, it would say something like, no such function then, or then undefined. It's a little weird and it's a little hazy, especially if you're not used to asynchronous programming. But we'll have a lot more time to talk about that in future days, especially with the API stuff. We'll get a lot more into how promises work. See what we got time-wise. All right. I don't want to keep everyone forever, and I don't want to stress my voice anymore. So we're going to get close to calling it the end of the first day, but we know where we want to go. We want to get to this point where I can string my functions together. We have our commands ready. We probably want to get into the point where we add other features, like we talked about frames. We probably want to add the concept of frames. We definitely want to add that required elements. And then we also wanted to have the concept of a dynamic locator. So one thing in terms of dynamic locators, say we had like a search result, and you want your test to be able to say, click the first search result, click the second, click the third, click the fourth. It's very common to see people create 15 elements for each search result. It would be nice if we had search result by line number. Right, if we could say, give me the search result of some line number. I don't know what it is, so I can say description. And we'll talk about how we do this, but we're going to say the right. We want to be able to say this. I'm clicking the whatever you say. You tell me search result. And we can actually just change this to. All right. And then we'll have our locator. It's going to be some sort of locator, you know, something, something, something. And then it's also going to have some piece of information, right? And like if you're doing CSS, it might be ID, nth child, and something. So this is a concept we're going to want to build too, is making this is going to allow you to make very flexible page objects where you can mix and match the interesting stuff around there. And then we'll take it from there. We'll see. We'll get the API portion as well. But the key thing to take home is this took roughly an hour. It would take even less in a language that you're familiar with. And you can build a framework off of this right now. You can add to it. You can just start going through your tests. And as you add elements, you add commands is what you need to do. Right now, I click and type. At some point, I might need read or is visible or assert is visible. And I can just add to it as I go and add features as I go. So stay tuned. We'll get to some more interesting stuff for sure.